For our pitch, we selected a line following robot with logic that could be implemented in industrial warehouses where self-driving robots are implemented, a field that we foresee blossoming in the future. We have a robot that is on a 3D printed chassis and with a caster on the back. There are two 12-volt motors connected to wheels, and those are connected to 9-volt battery through a 5-volt power supply. There is an ultrasonic sensor that sends and receives a signal to determine the distance from an object in front of it, and an infrared sensor to detect black lines below it. The system demonstration video shows the video following a track that we made. It starts up and follows the line and stops when there's an object presented in front of it, and then continues when the object is removed. It works well because of the combination of the speed that the robot travels at, which is somewhat slow, and the code that being reacting very fast, 2 turns. Anytime it's on a line, it'll immediately turn to correct. We made the turning reactive by having the drive controls before the ultrasonic sensor stop code. When designing, we decided that our first order of business was getting the vehicle to go forward. Thanks to our planning ahead, our circuit worked great, and we were able to focus primarily on the coding side of the project. We got it to move forward super fast, and when we were able to focus on the turning and an integration of sensors, which broke our code each and every time. It took many iterations, even though we were able to finalize the code, but we were able to identify the issue because we would get something to work and then put something new in, and then it would break, and then so we would know that it was a logic issue.